let's find this limit. Now you know I'm not going to just plug in that 4. If I do, I end up with a denominator that is 0. So there's definitely something going on. Sounds like we have an asymptote coming. We can factor the bottom. When we do, we've got x and 9 up top, down low, x plus 9, x take away 4. Oh, look at that. These x plus 9s, they can go. After they do, we're looking at the limit as x approaches 4 of 1 divided by x minus 4. It's not looking so good. If I go ahead and plug in that 4, what I see is 1 divided by 4 minus 4, which is 1 divided by 0. And that is undefined. Hold up. Now let's think about that original function. Now this is what we started with. We were able to factor the bottom into x plus 9 and x take away 4. We had this repeated factor. That means that if we were looking at the graph, we would have a hole at x equals -9. That would be removable. We also find that we've got a vertical asymptote, that's a boundary, at x equals 4, and that is not removable. So what does this mean? If we take a look at a lazy graph, we know that x is not supposed to go to 4, not at all. That's a vertical boundary. Now I am going to be very lazy. We also know that by the time we get to 9, the graph is going to get close, no touching, we've got a hole, so there is a gap. Something's going on the other side. I'm not taking great care. Something's definitely going on. But notice as you look from the left and right sides, from the left, as we get close to x is 4, that graph is approaching negative infinity. Whereas, if we take a look from the right, as we get close to x is 4, see how those y's are approaching positive infinity. Well, that's not a match. So we would conclude that this limit does not exist. Okay.